Hello there and welcome to the series of videos that's going through the content of A-Level Maths. Here we're looking at the Introduction to Integration chapter so we can answer questions from exercise 13a and b. So, integration, just to introduce it, is the reverse process of differentiation. So let's think about how we differentiate and then we'll reverse that process. So, with differentiation we start with our function and the first thing we do is we multiply our power by the number at the front, and we bring the power to the front. The next thing we then do is we reduce the power by 1, or subtract 1 from the power, and that gives us then our gradient function. So integration is the process of doing exactly that in reverse. So we effectively start with the gradient function and we work back upwards to our function. So what you'll see here is that instead of reducing the power by 1 when we're integrating, we have to increase our power by 1. And instead of multiplying by the power, we divide by the new power that we've created once we've added on 1 to our power. And that gives us our original function. So what you'll hear me say a lot in this video here is increase the power by 1, divide by the new power. And the reason I'm referring to the new power here is because it's the power once you've already increased the power by 1, not the old power in the start of the question. So increase by 1, divide by the new power. Okay, so what if we had to integrate 2x? Now this is the famous one here. Y equals x squared, we should know this one off by heart now, will give us dy by dx equals 2x. So the answer should be y equals x squared, right? Well, what about if we had y equals x squared plus 5? The differential there would also be 2x. What about if we had y equals x squared minus 7? The answer there would be dy by dx equals 2x. So if we're integrating 2x, there are loads of different answers that we can have. We can have x squared, we can have x squared plus 5, we could have x squared minus 7. So what we say here is that integrating 2x should give us x squared, but there will also be a number at the end that we don't know what that could be. It could be a plus 0, it could be a plus 5, it could be a minus 7. So what we write in general is, if dy by dx equals x to the n, then we increase the power by 1, divide by that new number, and then we add on c. So that's effectively representing add on 5 or take away a 7, the number that will disappear when we differentiate to get our gradient function. So this number here is always required at the end of an integration question. The reason is because when you differentiate this function here now, you're going to get this plus c bit will disappear. If it was a plus 5, differential of 5 is 0. Okay, so we must include it at the end of every integration question. And we can also write this in function notation, f dash x equals x to the power of n, then we increase the power by 1 and divide by the new power plus c. Okay, let's have a go at some questions now then. So dy by dx equals x to the 4. So the first thing we need to do here is increase the number 4 to the number 5 and then divide by that number 5. So it's x to the 5 divided by 5. Add c. Don't forget to add that c, because the reason is because if we were to differentiate this function and go backwards up here, if we have like a plus 7 at the end, that plus 7 would differentiate to 0 and disappear. So that's why we need that there. Okay, dy by dx this time is equal to x to the power of minus 5. So increasing that number by 1 will get us to minus 4, because remember it will go up on the number scale, and then we divide by that minus 4. So we get x to the power of minus 4 divided by minus 4 plus c. Or in other words, it could be written as y equals minus a quarter x to the minus 4 plus c. Okay, let's have a go at a few more questions now. So similar idea to differentiation, you will just integrate these components here individually. So the first part here is going to be increase the x by 1, so it's now a 2, and divide by the number 2, so it's going to be 3x squared. The next part here, increase this number by 2, so it's going to be x to the minus 2, and divide by that number minus 2, and we get minus x to the minus 2. And the next part here, increase this number by 1, so we're going to get x to the minus 3 over 2. And when we divide by that 3 over 2 like this here. Now the way we would divide by the 3 over 2 here is we would kiss and flip. So it'd be 3, the number on the top, times by 2 over 3. So this would give us 6 over 3. Okay, so when you've got one number divided by a fraction, you times it instead, but flip the fraction upside down. Okay, simplifying the terms here now, so it's 3x squared minus x minus 2 and minus 2x to the power of 3 over 2. Okay, now you can always check your answer to these, because when you differentiate this, you should get back to your answer here. So just quickly differentiating this, we're going to get 6x, and then it's going to be plus 2x to the minus 3, and on this one here it's going to be minus 3x to the half, which is exactly what we've got in our question here. And plus c, don't forget to plus the c. Okay, so we also need to identify the notation used for integration, and instead of dy by dx, this time it's a bit of an elongated S symbol. So it's a little flick at the front, and then down, and a little flick at the end. So the integral of the gradient function is equal to the original function, and we've seen that already today. The integral of the gradient function with respect to x is equal to the function plus a constant. Okay, so let's have a little look at some questions here. So the integral of x to the power of a half plus 2x cubed. So this is going to be increase the power by 1 and then divide by the new power. And then on the same one here, increase the power by 1 and divide by the new power plus the c. Now remember, when we divide by fractions, we won't leave our answer as this. We're going to times and flip the fraction upside down. So it's going to be 2/3 x to the power of 3 over 2 plus a half x to the power of 4 plus the c. Okay, so hopefully this is becoming quite standard for you. So the integral of 4t squared plus 6 with respect to t, so increase the power by 1, divide by that new number 3. And then for the 6, well, the 6, remember that 6t differentiated just to 6, so effectively the reverse can happen here. We could also think of this as if we have 6t to the 0 to start with, we increase the power by 1, so it's now t to the 1, and divide by the new power, so it's now just divided by 1. So this is what we get. So if you're integrating just a number, then it will give you that number times whatever letter you're integrating with respect to, so x or t. Okay, another question here now. Right, we have p's and q's in here, and we differentiate with respect to x. So in this question here, increase the power by 1, divide by the new power on the first one, so that would just give us x cubed. Now the p here, just treat the p and the q as if they were numbers, so think of them both as number 3's. If it was 3x to the minus 2, you'd increase the power by 1, divide by the new power, so you would get minus 1 as the power over minus 1. And now thinking of q as the number 3 here, this would effectively just be a 9. So how do you integrate the number 9? It would just be 9x. So it's q squared x. Okay, so simplifying these fractions, we'll get x cubed minus px to the minus 1 plus q squared x plus the c. Okay, so treat p and q as just numbers. Right, okay, here we've got an integration question with a bit of a fraction in here now. So just as we did with differentiation, we have to split up this fraction into separate numerators. So in this case here, we split them up just like this. So we'll split up the numerators and keep the denominators on the bottom here just as they were before. And now we integrate. So, yeah, that's a good idea. So rewrite them as powers. So we can now increase the power by 1 and divide by the new power. So with the minus 3 over 2, the minus 3 over 2 will increase to a minus a half. So we're dividing by minus a half, which is the same as timesing by minus 2. So we'll write this out to start with. And for the next one here, it's increase the power by 1, so it's now minus 1 and divide by that new power. so just be minus 1 plus the c. Now simplifying all of this, remember we don't leave fractions on the bottom of a fraction, and we'll probably bring up the negatives as well. So it'll be 4/3 x cubed minus 2x to the power of minus a half minus 5x to the power of minus 1 plus the c. Okay, and we could rewrite this as fractions just like we've got here. Okay. Right then, your turn to have a go at some questions here. Pause the video and have a go at these 4. Right, okay, well done for having a go at these questions here. So for the first question here, it's going to be x. Now increase the number 4 to 5 and divide by that new number 5. And then it's going to be plus 2, increase the power on the 3 by 1, so it's now a 4. And divide by the new number 4, so it's going to be 2 over 4, which is a half, or x to the 4 over 2. And then we have to always plus c at the end. Okay, next question here, question 3, increase the power by 1, so it's now going to be a minus 1. And now divide by the new power, that'll be a 4 divided by minus 1, so that's going to be minus 4x to the power of minus 1. The next question here is going to be plus, increase the power by 1, so it's now a half, and divide by that new power, so dividing by a half will give us times by 2, which will make it 6x to the half. Plus c. And you can always check these by differentiating them. So what would you get if we differentiated this? Well, the minus 1 would times by the minus 4, so that'll give us 4, and divide and take away 1 from the power, so that'll be minus 2. And the same thing works with this one here. Right, so the next thing we're going to do on 6a here is split up our powers. Sorry, not split up our powers, split up the fraction into 2 different numerators and the same denominator on the bottom of both of them. So now it's just going to be the integral of 2x plus 3x to the minus 2 dx. So what we'll get here is x squared. Now for some of these, you can remember them off by heart. So I remember that the differential of x squared is 2x, so I know immediately the integral of 2x is x squared, and I can just do that immediately. And then for this one here, it's going to be take away 3x to the minus 1, increase the power by 1 is minus 1, and divide by the new power, so it would be a divide by minus 1, or in other words, times by minus 1. And the next one here, we're going to have to expand the brackets, so it's going to be x, not x squared, because we're going to expand root x plus 2 times root x plus 2 dx. So this is going to give us root x times root x is just x. Root x times 2 is 2 root x. And this is going to be plus another 2 root x for the other expansion, and then it's going to be plus 4 dx. So simplifying this, we're going to get x plus 4, and the square roots will be x to the power of halves plus 4 dx. And now we integrate, so it's going to be x squared over 2. And now we increase the power by 1, so it's now 3 over 2, divide by that new power, so that's going to be 8 over 3x to the power of 3 over 2. So remember, when we are dividing by a fraction, we times in the opposite way around. So it's divide by 3 over 2 onto 4, so it's effectively times by 2 over 3 onto 4, so it's 8 over 3. And then for any number that's just lingering at the end, the integral of that is just 4x plus the c. Right, well done for having a go at these questions. Make sure you do have lots more practice at these. Make sure you become a master of integration. So it really help you in the full A-level of your maths A-level. Right, make sure you persevere through the difficult ones and ask your teacher for help. Thank you very much.